Hey guys, welcome back. Today we're going to dive into a pretty cool topic, which is comparing ownership models in C++ and Rust. Both languages are really powerful, but they approach ownership in different ways. So let's break it down. Starting off, what is ownership? What do we mean by ownership? Basically, it's all about who's responsible for managing resources like memory. In programming, owning something usually means you're responsible for cleaning it up when it's no longer needed. Ownership is important because it allows us to reason about who is in control of what resource and exactly when resources are obtained and destroyed or freed. Now in C++, ownership is generally managed through destructors, copy constructors, and assignment operators. We also have things like smart pointers, like shared pointer and unique pointer to help manage ownership. Uh, let's include some relevant headers here. So we can make a new pointer, a unique pointer to an int with uh, the make unique function, and unique pointers represent unique ownership, as in uh, this pointer owns the data. We control the data. Nobody else can access it or write to it, and we are also responsible for cleaning up the data afterwards. So what's nice about unique pointers is that when they go out of scope, the destructor frees the memory it points to. Now, shared pointers model something different. Uh, a shared pointer models shared ownership, as the name would suggest. And shared ownership means we use reference counting to determine how many owners we have to an object at any given time. And when the reference count drops to 0, we free the memory and give it up back to the operating system. So smart pointers are very good for modeling ownership in C++, and you should use them and avoid raw pointers whenever possible. I think raw pointers are pretty useful sometimes, but in general, you should try to stay away from them if you can, just to make sure it's clear smart pointers allow you to model ownership and convey that meaning to yourself or future developers who work on the project. Now let's compare it to Rust ownership. So Rust uses a strict ownership model where each value has a single owner and borrowing rules are checked at compile time. So you can't to own a value, you have to be the only owner, and uh, if you want access to the data, you'll have to request it from that owner. And you can request a mutable reference or just a immutable reference. You can have many immutable references, but only one mutable reference and no other immutable references at the same time. And this allows us to be more strict about who owns the data and who has access, read or write access to it at any given point. Let's give a quick example here. So let's create a string from this literal, and let's copy that into S2. Now, if you're coming from C++, you're like, okay, S2 now points to different memory that holds the same characters. Actually, we transferred ownership from S1 to S2 here. S1 no longer owns the data, and we cannot do anything with S1. We can't modify S1. We can't use S1 to give ownership to anyone else. We have to ask S2 for ownership. The compiler won't even let us interact with S1 at all anymore. It's basically a piece of crap that we don't need. So in C++, in general, we copy things by default, but in Rust, we move things by default. We don't create a new object and the new object owns it, a new copy of the data. In fact, we use the same data, but the new object owns it, and the old one has released ownership of the object to the new object. Or rather, it releases ownership of the data to the new object. Now, C++ gives you a lot of flexibility, but you don't have to, because you don't have to be as explicit about ownership. Now, this is a positive because it's more straightforward to write, but it's also a downside because people reading your code might, and the compiler itself, have less information to work with when reasoning about your program. The Rust ownership model gives you a nice way to describe to the compiler and to other people what's going on here and who owns which data. With smart pointers, you can model very similar things in C++ as you can with Rust, box, and reference counter, but it's still a little bit more explicit in Rust, and you just have to choose which one you're more comfortable with. So that about wraps it up. I hope that this comparison gave you a good idea of how C++ and Rust approach ownership. You'll want to look at more videos for a deeper dive on each language, but my goal with this is just to give you a head start in comparing the languages. Now, if you like that video, just feel free to give it a like, and I'll catch you next time.